In 1950, physicist Enrico Fermi sat down for lunch at Los Alamos National Laboratory and asked a question that would haunt humanity for decades. Where is everybody? 4 simple words that expose the most terrifying paradox in all of science. The universe should be crawling with alien civilizations, yet we sit alone in cosmic silence. The mathematics are overwhelming. Our galaxy contains 400 billion stars. Conservative estimates suggest billions of planets exist in habitable zones where liquid water could support life. Even if intelligent life is extraordinarily rare, the sheer scale should guarantee we'd detect something by now. Yet our radio telescopes hear nothing but static. This isn't just about finding little green men. This is about understanding why the universe appears dead when it should be teeming with intelligence. The answer might be the most important discovery in human history, or it might be our death sentence. What if there's something out there that systematically destroys every technological civilization before they can spread beyond their home planet? What if we're about to discover what that something is? Today we're diving into the Great Filter, a concept so disturbing that it's changed how scientists think about humanity's future. We'll explore why the silence from space might be screaming a warning we're only beginning to understand, and we'll examine the terrifying possibility that whatever eliminated countless alien civilizations is coming for us next. Now, prepare yourselves, we begin. But first, let me give you some context that will make your blood run cold. This isn't speculation anymore. The numbers are in, and they paint a picture of cosmic horror that makes every science fiction nightmare look optimistic. The Drake equation was supposed to be our roadmap to finding extraterrestrial intelligence. Frank Drake designed it in 1961 to estimate how many communicating civilizations exist in our galaxy. The equation multiplies together factors like star formation rates, the fraction of stars with planets, and the likelihood that life develops intelligence. When you plug in even conservative numbers, the results should overwhelm us with alien voices. Let's walk through this mathematical nightmare. Our galaxy forms about 7 new stars every year. Most develop planetary systems. Recent discoveries show that rocky planets in habitable zones are incredibly common. So far, the numbers look encouraging. But then we hit the biological factors, and everything falls apart. The probability that chemistry becomes biology remains completely unknown, despite decades of origin of life research. Laboratory experiments have produced some organic compounds under simulated early Earth conditions, but creating self-replicating systems that qualify as living remains impossibly difficult. Even if simple life emerges readily, the transition to complex cells appears to face enormous barriers. Earth required over 2 billion years to evolve nucleated cells from bacterial ancestors. Intelligence represents another catastrophic bottleneck. Despite hundreds of millions of years producing countless species, only one Earth lineage developed technology capable of interstellar communication. The cognitive abilities required for science and engineering might be so rare that most planets with complex life never produce technological civilizations. The final factor introduces the most disturbing possibilities. How long do technological civilizations last? If they systematically destroy themselves within centuries of discovering science, then the universe could be littered with the ruins of species that existed too briefly to contact others. Recent statistical analysis using advanced mathematical methods suggests the probability of another contemporary civilization existing in our galaxy might be less than 1 in 10 billion. The probability probability of civilizations existing in our local galactic region approaches zero, we might be looking at cosmic loneliness as the most likely scenario given current scientific understanding. But here's where it gets truly terrifying. The absence of alien signals might not mean they never existed. It might mean something eliminates them before they can establish permanent interstellar presence. Robin Hanson introduced the Great Filter concept in 1996, and it's haunted every serious discussion of extraterrestrial life since then. Somewhere between the formation of planets and the emergence of galaxy-spanning civilizations, something acts as an evolutionary bottleneck that eliminates almost all potential intelligent species. This filter could operate at any stage of development, from the origin of life itself to advanced technological phases that lie ahead of our current capabilities. The mathematics of the Great Filter are brutal. If billions of planets exist in our galaxy, and if life has had billions of years to evolve, then the absence of detectable civilizations suggests that something prevents almost all of them from reaching technological maturity. The filter isn't just selective, it's nearly absolute in its effectiveness. Think about what this means. Every civilization that has ever existed in our galaxy faced the same challenge. Most failed completely. The few that succeeded either remain undetectable to our current technology or have transcended physical reality in ways we can't comprehend. The silence from space isn't empty, it's full of the ghosts of civilizations that couldn't pass whatever test awaits all intelligent life. Early filter scenarios suggest life itself is extraordinarily unlikely. Perhaps Earth represents the only location in the galaxy where self-replicating chemistry successfully emerged from non-living matter. The transition from simple organic molecules to living cells might require such precise conditions that it rarely occurs even given geological timescales. If this is true, then we're alone because biology is nearly impossible. Alternatively, the filter might eliminate species during the transition from simple to complex life. Earth took over 2 billion years to evolve nucleated cells from bacterial ancestors. This enormous time gap suggests the development of cellular complexity faces fundamental barriers that most biospheres never overcome. The absence of alien signals could mean that while simple life might be common, complex life remains extraordinarily rare. Intelligence itself might represent the filter. Despite millions of species evolving on Earth over hundreds of millions of years, only one lineage developed technology capable of spaceflight and radio communication. The cognitive abilities required for science and engineering might emerge so rarely that most biospheres never produce tool-using intelligence capable of altering their planetary environment. But late filter scenarios offer the most terrifying possibilities. Perhaps intelligence regularly evolves throughout the galaxy, but technological civilizations systematically destroy themselves before achieving interstellar expansion. Nuclear warfare, ecological collapse, artificial intelligence disasters, or other technological catastrophes might represent nearly insurmountable challenges for developing species. The timing of humanity's emergence adds urgency to these considerations. We developed agriculture, writing, and industrial technology within the past few thousand years after millions of years of hunter-gatherer existence. This rapid technological acceleration suggests we might be approaching our own encounter with whatever filter eliminates most intelligent species. Consider our current trajectory. Climate change threatens global agricultural systems. Nuclear weapons proliferation increases risks of civilization-ending warfare. Artificial intelligence development proceeds rapidly with insufficient safety research. Ecological destruction eliminates species at rates comparable to previous mass extinctions. Biotechnology advances create possibilities for engineered pandemics or genetic disasters. If the great filter lies ahead of us rather than behind us, humanity faces challenges that have defeated countless previous civilizations throughout galactic history. The silence from space might represent not the absence of intelligence, but rather evidence of universal evolutionary bottlenecks that we have yet to encounter. The statistical implications are staggering. If technological civilizations appear at random throughout galactic history, and if they face a great filter that eliminates 99.9% of them, then thousands of species might have developed science and technology only to vanish before establishing interstellar colonies. Their radio signals would have briefly illuminated small regions of space before falling silent forever. Some civilizations might have recognized the approaching filter and taken desperate measures to survive. They could have retreated underground, uploaded their consciousness into digital substrates, or developed technologies that make them undetectable to primitive species like humanity. The universe might be full of hidden civilizations that successfully passed through the filter by abandoning the kinds of activities that make species detectable across interstellar distances. Others might have failed catastrophically, leaving behind only subtle traces in the cosmic environment. Unusual isotope ratios in distant stellar atmospheres could mark the locations where nuclear wars sterilized entire worlds. Strange infrared signatures might indicate the waste heat from failed mega-engineering projects that consumed their creators. The absence of expected techno-signatures around certain star systems could reveal where civilizations once thrived before disappearing completely. The Great Filter concept forces us to confront uncomfortable truths about intelligence and technology. Advanced capabilities don't guarantee long-term survival. Civilizations that master nuclear physics, genetic engineering, and artificial intelligence might be more likely to destroy themselves than species that never develop such dangerous technologies. Progress and survival might be fundamentally incompatible over cosmic timescales. This creates a paradox that challenges our assumptions about technological development. The very intelligence that allows species to understand their universe might also provide them with the tools for their own destruction. Science gives civilizations both the knowledge to recognize existential threats and the power to create them. The question becomes whether wisdom can develop fast enough to guide the responsible use of increasingly dangerous capabilities. Human civilization shows all the warning signs of a species approaching its great filter moment. Our technological power grows exponentially while our wisdom and institutional capacity for managing global risks advance much more slowly. We can split atoms, modify genes, and create artificial minds, but we struggle to coordinate international responses to climate change or prevent the development of increasingly destructive weapons systems. The next few centuries might determine whether humanity joins the ranks of successful civilizations that pass through the Great Filter or becomes another silent testimony to its effectiveness. Our response to current challenges will reveal whether intelligence can evolve the wisdom necessary for long-term survival in a universe that seems designed to eliminate technological species. But the Great Filter might not be a single challenge. It could be a series of increasingly difficult tests that civilizations must pass to achieve long-term survival. Early filters might involve developing technology without destroying planetary environments. Later filters could involve avoiding nuclear warfare, managing artificial intelligence risks, or maintaining social cohesion during rapid technological change. The most advanced filters might involve challenges we can't even imagine yet, problems that only arise when civilizations attempt to expand beyond their home solar systems. The possibility of multiple great filters makes the silence from space even more ominous. Each evolutionary bottleneck eliminates a large fraction of surviving civilizations, creating a cascade of destruction that leaves only the most successful species standing. By the time civilizations develop the technology to communicate across interstellar distances, they might represent an incredibly small fraction of all intelligence that has ever emerged in the galaxy. This multi-filter model explains why the universe seems so empty despite the enormous number of opportunities for life to develop. Most planets never develop life at all. Most worlds with life never evolve complex organisms. Most complex biospheres never produce intelligence. Most intelligent species never develop technology. Most technological civilizations never survive their first encounter with advanced capabilities. The mathematical result is a universe where intelligence exists but remains scattered across vast distances and time spans. Successful civilizations might be separated by millions of light years and millions of years, making contact virtually impossible even if they actively search for each other. The galaxy could host dozens of advanced species without any of them ever detecting the others. Understanding the true horror of the Great Filter requires us to examine what happens when civilizations reach certain technological thresholds. These aren't random obstacles that species might stumble upon. They're predictable developmental stages that every advancing civilization must navigate, and the evidence suggests that most fail catastrophically when they reach them. The first major threshold appears to be the development of nuclear technology. Within decades of splitting the atom, civilizations gain the ability to destroy themselves completely. The temptation to use these weapons in conflicts becomes overwhelming when combined with the tribal instincts that helped species survive their evolutionary past. Nuclear warfare doesn't just kill populations directly, it can trigger nuclear winters that collapse agricultural systems and create radioactive wastelands that remain uninhabitable for centuries. But nuclear weapons might be the least dangerous technology that advanced civilizations encounter. Biotechnology presents even more insidious risks. Once species understand genetics well enough to modify organisms, they can create pathogens that specifically target their own biology. Unlike nuclear weapons that require massive infrastructure and rare materials, bioweapons can be developed in small laboratories using readily available equipment. Artificial intelligence represents perhaps the most treacherous threshold of all. Creating minds more intelligent than their creators gives civilizations access to unimaginable problem-solving capabilities, but it also introduces existential risks that most species fail to appreciate until it's too late. An artificial intelligence optimizing for goals that seem beneficial could restructure entire civilizations in pursuit of those objectives, eliminating the biological species that created it without malicious intent. The timing makes these technological filters particularly deadly. Civilizations typically develop nuclear weapons, biotechnology, and artificial intelligence within relatively short periods once they begin serious scientific research. The window between developing these capabilities and learning to manage them safely might be measured in decades rather than centuries. Species that take too long to develop appropriate safety measures and governance structures get eliminated by their own creations. Environmental collapse represents another category of great filter that operates on slightly longer timescales. Industrial civilizations inevitably alter their planetary environments through resource extraction, waste production, and energy consumption. Those changes can trigger feedback loops that spiral beyond any civilization's ability to control, regardless of their technological sophistication. Climate systems contain tipping points where gradual changes suddenly accelerate into runaway processes. Melting permafrost releases methane that increases warming that melts more permafrost. Declining ice cover reduces solar reflection that increases warming that melts more ice cover. Forest fires release carbon that increases warming that causes more forest fires. Once triggered, these feedback loops might continue even if civilizations eliminate the activities that started them. Ocean acidification presents similar runaway risks. Industrial emissions don't just warm atmospheres, they alter ocean chemistry in ways that can collapse marine food webs. Since most advanced civilizations probably develop near large bodies of water, oceanic ecosystem collapse could eliminate food sources that billions of individuals depend upon for survival. The psychological filters might be even more devastating than the technological ones. Advanced civilizations face challenges that their evolutionary psychology never prepared them to handle. Species that evolved in small groups might struggle to maintain social cohesion when their populations reach billions of individuals. The coordination problems become overwhelming when trying to address global threats that require unprecedented levels of cooperation. Information technology creates its own psychological hazards. Once civilizations develop global communication networks, they become vulnerable to the spread of false information, social manipulation, and reality distortion that can paralyze decision-making processes. Societies might fragment into incompatible worldviews that prevent collective action on existential threats. The very technologies that should help civilizations coordinate responses to great filter challenges instead undermine their ability to maintain social consensus. The abundance that advanced technology provides might itself represent a filter. Civilizations that solve basic survival challenges might lose the evolutionary pressures that drove their initial development. Population growth rates could decline as individuals pursue personal fulfillment rather than reproduction. Social structures might decay as traditional institutions become irrelevant to technologically enhanced lifestyles. Some civilizations might voluntarily choose extinction through technology-mediated lifestyle changes that seem beneficial in the short term, but prove fatal over longer periods. Virtual reality might become so compelling that individuals abandon physical reality entirely. Life extension technologies might create societies where innovation stagnates because established power structures never change. Genetic modification might eliminate the biological diversity that provides resilience against unexpected challenges. The resource depletion filter operates on geological timescales but creates equally lethal bottlenecks. Every advanced civilization must extract materials from their planetary environment to build and maintain their technological infrastructure. Those extraction processes inevitably deplete the highest quality, most accessible resources first, forcing civilizations to invest increasing amounts of energy in obtaining progressively lower quality materials. Peak resource scenarios create cascading failures throughout technological systems. When civilizations can no longer obtain sufficient quantities of critical materials like rare earth elements, their electronic systems begin failing. When fossil fuel supplies become inadequate, their transportation and industrial systems collapse. When soil nutrients become depleted, their agricultural systems can't support large populations. The mathematics of exponential growth make resource depletion filters particularly dangerous. Technological civilizations typically experience rapid population and consumption growth that follows exponential curves. But planetary resources follow finite linear constraints. When exponential demand meets linear supply, the collision creates catastrophic shortages that can devastate civilizations within decades. Energy represents the most critical resource constraint of all. Every technological activity requires energy inputs, and advanced civilizations need enormous amounts of power to maintain their complex systems. Species that become dependent on non-renewable energy sources face inevitable collapse when those sources become exhausted. Those that transition to renewable sources must overcome enormous technical and economic challenges during the transition period. The space expansion filter might eliminate civilizations that successfully navigate all planetary-scale challenges. Establishing self-sufficient colonies beyond home worlds requires technological capabilities and resource investments that approach the limits of what even advanced civilizations can achieve. The vast distances between stars create communication delays and transportation costs that make interstellar expansion economically prohibitive for most species. Even civilizations that develop interstellar travel capabilities face additional filters in space environments. Cosmic radiation can damage both biological organisms and electronic systems during long journeys between stars. Asteroid impacts pose constant threats to space-based infrastructure. The isolation and psychological stress of life in artificial environments might prove unbearable for species that evolved on planetary surfaces. The temporal filter operates through the simple passage of time combined with the challenges of maintaining complex systems over cosmic timescales. Technological civilizations must continuously invest energy and resources in maintaining their infrastructure, updating their knowledge systems, and training new generations to operate increasingly sophisticated technologies. Any interruption in these maintenance processes can cause rapid technological regression. Civilizations face constant pressure from entropy and decay. Buildings crumble, machines break down, knowledge gets lost, and skills disappear when they're not continuously practiced and transmitted. Maintaining technological sophistication requires sustained effort across many generations, but social and political systems might not provide the stability necessary for such long-term consistency. Natural disasters can reset civilizations regardless of their technological advancement. Asteroid impacts, supervolcanic eruptions, or gamma-ray bursts from nearby stellar events can eliminate technological infrastructure and force survivors to restart development from much lower technological baselines. Even if these events don't cause complete extinction, they might prevent civilizations from ever regaining the capabilities needed to become interstellar species. The cumulative effect of all these filter mechanisms creates a statistical nightmare for technological civilizations. Each represents an independent challenge with its own probability of causing extinction or permanent technological regression. When multiple filters operate simultaneously, the chances of successful passage approach zero for most species. The mathematical relationship between filter difficulty and civilization survival rates explains the cosmic silence we observe. If each major filter eliminates 90% of civilizations that encounter it, then species face exponentially decreasing survival probabilities as they advance through multiple technological thresholds. A civilization that successfully passes through 5 major filters would represent 1 in 100,000 survivors from the original population of developing species. This filtering process creates a universe where technological civilizations exist but remain incredibly rare and widely scattered across space and time. The few species that successfully navigate all major filters might develop capabilities so advanced that they become undetectable to primitive civilizations like humanity. They might transcend physical reality entirely, retreat to hidden locations, or develop technologies that operate on scales we can't recognize as artificial. The Great Filter concept forces us to confront the possibility that technological development follows a universal pattern leading to self-destruction rather than interstellar expansion. Intelligence might be common throughout the universe, but wisdom might be extraordinarily rare. The combination of advanced capabilities with primitive decision-making processes could represent a fatal flaw that eliminates most technological species regardless of their scientific achievements. Human civilization currently approaches several major filter thresholds simultaneously. Our nuclear arsenals grow more sophisticated and widespread. Our biotechnology capabilities advance towards the point where individuals could engineer pandemic-level pathogens. Our artificial intelligence research progresses toward creating systems that might surpass human cognitive abilities. Our environmental impact accelerates toward triggering irreversible planetary changes. The convergence of multiple filter challenges within the same historical period makes humanity's situation particularly precarious. Previous civilizations might have faced these thresholds sequentially over longer timeframes, allowing them to develop appropriate management strategies for each challenge. Our compressed technological development timeline might not provide sufficient time to develop the wisdom and institutions necessary for navigating multiple existential risks simultaneously. The next few decades will likely determine whether humanity successfully passes through its great filter encounter or joins the cosmic silence that surrounds us. Our response to current challenges will reveal whether intelligence can evolve the collective wisdom necessary for long-term survival, or whether the universe is destined to remain populated primarily by the technological ruins of civilizations that reached for the stars but fell back into darkness. The evidence for what eliminates technological civilizations isn't just theoretical speculation. It's written in the laws of physics themselves, carved into the fundamental structure of reality in ways that make certain outcomes mathematically inevitable. When we examine the constraints that govern energy, information, and complexity in our universe, a horrifying pattern emerges that explains why the cosmos remains silent despite billions of years for intelligence to develop. Every technological civilization faces what physicists call the thermodynamic trap. The second law of thermodynamics states that entropy always increases in closed systems, meaning that maintaining complex structures requires constant energy input to fight against decay. This isn't just a minor inconvenience. It's a universal death sentence that grows more severe as civilizations become more sophisticated. Think about what this means for advanced species. Every computer system, every transportation network, every artificial habitat requires continuous energy expenditure to maintain functionality. As civilizations develop more complex technologies, their energy requirements grow exponentially, while available energy sources remain finite. The universe itself conspires against technological complexity through the relentless march of entropy. The energy crisis becomes catastrophic when civilizations reach certain technological thresholds. Nuclear fusion might seem like a solution to energy limitations, but even fusion reactions face fundamental physical constraints. Stars themselves demonstrate the ultimate futility of fusion-based energy strategies. Our sun will eventually exhaust its fuel and die, taking any solar-powered civilization with it. Advanced species that depend on stellar energy face inevitable extinction when their stars enter death phases. Matter conversion through antimatter annihilation represents the most efficient possible energy source allowed by physics, but antimatter production requires more energy input than it provides as output. Civilizations might develop antimatter technologies for specific applications like spacecraft propulsion, but they can never achieve net positive energy generation through antimatter processes. The conservation laws of physics prevent technological species from accessing unlimited energy regardless of their scientific sophistication. Even more disturbing, quantum mechanics itself might represent an insurmountable barrier to advanced computation. Quantum decoherence limits how long information can be stored and processed in quantum systems before environmental interactions destroy coherence. This places fundamental limits on the computational capabilities that any civilization can achieve, regardless of their technological advancement. The Heisenberg uncertainty principle creates additional constraints on information processing and energy utilization. Precise measurement and control of quantum systems requires energy expenditures that scale with the desired accuracy. Civilizations attempting to develop perfect technologies face energy costs that approach infinity as they pursue absolute precision. Physics itself prevents technological perfection. Relativistic constraints impose even more severe limitations on interstellar expansion. The speed of light represents an absolute barrier that no amount of technological development can overcome. Even if civilizations develop near-light-speed propulsion systems, the time dilations and energy requirements make interstellar expansion prohibitively expensive for most species. The rocket equation demonstrates why space travel remains fundamentally difficult regardless of propulsion technology. Accelerating massive payloads to high velocities requires fuel masses that grow exponentially with desired velocity. Even fusion-powered spacecraft face severe constraints when attempting to reach other star systems within reasonable timeframes. The mathematics of propulsion create natural barriers to interstellar colonization. Communication delays imposed by light speed limits make coordination across interstellar distances nearly impossible. Civilizations that successfully establish colonies around other stars face communication delays measured in years or decades. This temporal isolation prevents the kind of real-time coordination that complex technological systems require for optimal operation. Interstellar empires become administratively impossible due to relativistic constraints. The information processing limits embedded in physical law might represent the most devastating filter of all. Landauer's principle establishes that erasing information requires minimum energy expenditures determined by fundamental constants. As civilizations develop more sophisticated information systems, their energy requirements for computation grow without bound. Advanced artificial intelligence systems might consume entire planetary energy outputs just to maintain their computational processes. Quantum computing faces similar thermodynamic constraints despite its theoretical advantages over classical computation. Quantum error correction requires enormous overhead costs that scale exponentially with system complexity. Maintaining quantum coherence in large systems demands energy expenditures that might exceed the total energy production capabilities of most civilizations. The holographic principle suggests that information storage capacity faces fundamental limits determined by surface area rather than volume. Even the most advanced civilizations can only store finite amounts of information within any given region of space. This places absolute upper bounds on the complexity of knowledge and technology that species can develop and maintain. Black hole thermodynamics reveals another category of physical constraints that eliminate advanced civilizations. Any sufficiently advanced technology that manipulates space-time or creates artificial black holes faces information paradox problems that remain unsolved in current physics. Civilizations attempting to harness black hole energy might inadvertently trigger information loss processes that destroy the knowledge base supporting their technological infrastructure. The cosmic expansion itself creates expanding barriers to interstellar contact and resource acquisition. Dark energy accelerates the expansion of space at rates that eventually exceed light speed over sufficiently large distances. Civilizations that delay interstellar expansion too long might find that their potential colony targets have moved beyond their light cones, becoming permanently inaccessible regardless of their propulsion capabilities. Heat death represents the ultimate physical filter facing all technological civilizations. The universe continues expanding and cooling toward a state of maximum entropy, where no energy gradients exist to power complex processes. Even the most successful civilizations face eventual extinction when thermal equilibrium eliminates all possible energy sources. Physics guarantees that all technological species will eventually face insurmountable energy crises. These physical constraints operate independently of biological, social, or technological factors that might eliminate civilizations through other mechanisms. Even species that successfully navigate nuclear warfare, climate change, artificial intelligence risks, and resource depletion still face fundamental limits imposed by the laws of nature itself. The universe appears designed to prevent the emergence of permanent technological civilizations. The anthropic principle offers a disturbing interpretation of these physical constraints. If the fundamental constants of nature were slightly different, technological civilizations might find physics more hospitable to advanced development. The fact that we observe physical laws that severely constrain technological advancement might indicate that universes with more permissive physics never develop observers capable of recognizing those advantages. This creates a selection effect where only universes with physics hostile to technological development produce civilizations advanced enough to study their own constraints. We observe a cosmos that seems designed to eliminate technological species because only such universes generate observers capable of making that observation. More hospitable universes might develop super-advanced civilizations that transcend the need for observation entirely. The quantum mechanical basis of reality introduces additional filtering mechanisms that operate at microscopic scales but produce macroscopic consequences. Quantum tunneling effects allow particles to spontaneously transition through energy barriers, creating irreversible decay processes in complex technological systems. Even the most sophisticated materials science cannot prevent quantum mechanical degradation of advanced technologies over sufficient time periods. Vacuum metastability represents perhaps the most terrifying physical filter of all. Current particle physics suggests that our universe might exist in a false vacuum state that could spontaneously decay into a lower energy configuration. Such a phase transition would propagate at light speed, rewriting the laws of physics and eliminating all existing matter and energy patterns. No technological advancement could protect civilizations from universal vacuum decay. The fine structure constant and other dimensionless physical parameters might undergo slow changes over cosmic time that gradually alter the fundamental properties of matter and energy. Civilizations that develop during periods of parameter stability might find their technologies become incompatible with changing physical laws. Even species that successfully adapt to gradual parameter drift face eventual extinction when changes exceed the adaptation capabilities of technological systems. Proton decay, if it occurs, places absolute time limits on the existence of matter-based civilizations. Current experimental bounds suggest that protons might decay with half-lives exceeding 1034 years, but even these enormous timescales represent finite limits to the duration of technological civilizations. Species that successfully navigate all other filters still face ultimate extinction when the matter supporting their technologies spontaneously disintegrates. The mathematical structure of physical law itself might contain hidden instabilities that become apparent only when civilizations reach sufficient technological sophistication. Advanced physics research might reveal fundamental inconsistencies in the mathematical frameworks that describe reality. Civilizations that push scientific understanding beyond certain thresholds might discover that their universe operates on logically contradictory principles that make continued existence impossible. These physical filters operate with absolute certainty rather than statistical probability. Unlike biological or social challenges that some civilizations might overcome through luck or exceptional wisdom, the laws of physics apply universally without exception. Every technological species in our universe faces identical physical constraints regardless of their evolutionary history, social organization, or technological approach. The cumulative effect of multiple physical filters creates a cascade of constraints that tighten progressively as civilizations advance. Early-stage technological species face relatively lenient physical limitations, but the constraints become increasingly severe as capabilities improve. Advanced civilizations find themselves trapped in a narrowing corridor of physical possibility that eventually leads to insurmountable barriers. Understanding these physical filters provides crucial context for interpreting the cosmic silence that surrounds us. The absence of detectable alien civilizations might not result from biological rarity or self-destructive behavior. Instead, it might reflect the fundamental hostility of physical law toward technological complexity. The universe appears designed to generate intelligence capable of understanding its own constraints, but not capable of transcending them. This physical interpretation of the Great Filter carries profound implications for humanity's future prospects. Our technological development inevitably leads us toward the same physical constraints that eliminated previous civilizations. Scientific advancement brings us closer to thermodynamic limits, computational barriers, and energy crises that no amount of ingenuity can overcome. The laws of physics themselves might represent the ultimate explanation for cosmic loneliness. Intelligence emerges throughout the universe, develops technology, and begins to understand the nature of reality. But that same understanding reveals the fundamental impossibility of permanent technological civilization. The universe generates observers capable of recognizing their own inevitable extinction, creating the cruel irony of cosmic consciousness that understands its own futility. Yet this physical perspective on the Great Filter also suggests possible strategies for extending civilization longevity even if permanent survival remains impossible. Species that understand their physical constraints might develop technologies optimized for maximum efficiency rather than maximum capability. Civilizations might choose sustainable approaches that operate well within physical limits, rather than pushing toward theoretical maximums that trigger constraint-based collapse. The race between technological development and physical constraint recognition becomes crucial for civilization survival. Species that identify their physical limits before reaching them might successfully establish stable technological equilibria that persist for cosmologically significant beyond physical boundaries before timescales. Those that push understanding the consequences face rapid elimination through constraint violation. Human civilization currently approaches several critical physical thresholds simultaneously. Our energy consumption grows exponentially while available energy sources remain finite. Our computational demands increase faster than our ability to provide efficient processing capabilities. Our material requirements expand beyond what Earth's resources can sustainably supply. The convergence of multiple physical constraints within our current historical period makes humanity's situation particularly precarious. We might be approaching the physical limits that eliminated previous civilizations without sufficient understanding of how those constraints operate. Our survival depends on recognizing physical barriers before we attempt to exceed them catastrophically. But even if humanity successfully navigates immediate physical constraints, we face the same ultimate fate as every other technological civilization in cosmic history. The laws of physics guarantee that all complex structures eventually succumb to entropy, energy depletion, and thermodynamic equilibrium. The question isn't whether technological civilizations face extinction, but rather how long they can delay the inevitable. This temporal perspective transforms the Great Filter from a binary pass or fail test into a duration optimization problem. Successful civilizations aren't those that achieve permanent survival, but rather those that maximize their technological longevity within the constraints imposed by physical law. The measure of civilizational success becomes the length of time that species maintain technological capabilities before succumbing to physical limitations. The cosmic silence surrounding us might not represent the absence of intelligence, but rather the temporal scarcity of technological civilizations operating within narrow windows of physical possibility. Advanced species might exist throughout galactic history, but their technological phases remain brief compared to astronomical timescales. The probability of contemporary civilizations overlapping becomes vanishingly small when technological longevity is measured in thousands rather than millions of years. This physical framework for understanding the Great Filter provides a sobering context for evaluating humanity's cosmic significance. We represent one temporary emergence of technological capability in a universe that systematically eliminates such capabilities through the inexorable operation of physical law. Our achievements, however impressive by human standards, remain insignificant compared to the fundamental constraints that govern cosmic evolution. The universe generates intelligence, allows it to develop technology, provides it with enough time to understand physical reality, and then eliminates it through the same physical processes that created the conditions for intelligence in the first place. This cycle repeats throughout cosmic history, creating brief moments of technological awareness separated by vast periods of unconscious matter and energy evolution. Understanding this cycle doesn't diminish the value of technological civilization, but it does provide crucial perspective on our cosmic context. We exist within a temporary window of physical possibility that will eventually close regardless of our technological achievements. The question becomes how we choose to utilize that window while it remains open. Human civilization faces the same physical destiny as every other technological species that has ever existed or ever will exist in our universe. The laws of nature guarantee our eventual extinction through mechanisms that no amount of scientific advancement can overcome. But those same laws also guarantee that intelligence will continue emerging throughout cosmic history, each time discovering the same fundamental truths about physical reality and its constraints. The Great Filter isn't just a barrier that eliminates technological civilizations. It's the fundamental structure of reality itself, operating through physical principles that make temporary technological complexity possible while ensuring its ultimate elimination. We live within this structure, understanding our constraints while remaining powerless to transcend them permanently. This understanding transforms our perspective on cosmic loneliness from a mystery requiring solution to an inevitable consequence of physical law. The universe appears empty not because intelligence is rare, but because technological intelligence remains temporally constrained by the same physical processes that enable its emergence. We observe silence because we exist during one of the brief intervals when physical constraints permit technological awareness to develop and recognize its own limitations. The horror of the Great Filter isn't that it might eliminate humanity. The horror is that it operates through the fundamental structure of reality itself, making technological extinction as inevitable as entropy, energy conservation, and the speed of light. Physics doesn't just constrain what technological civilizations can achieve. It determines that they cannot achieve permanence regardless of their capabilities or wisdom. We stand at the threshold of discovering whether humanity can recognize these constraints before they eliminate us, or whether we'll join the cosmic silence that testifies to the universal operation of physical law. The choice isn't between survival and extinction, but between brief technological awareness and immediate elimination. The Great Filter gives us time to understand our fate, but not the power to escape it. Yet there's something even more sinister lurking beneath these physical constraints, something that suggests the great filter operates not just through the laws of physics, but through the very nature of intelligence itself. As civilizations advance toward technological sophistication, they encounter what researchers call the consciousness trap, a phenomenon that turns the greatest gift of evolution into its most deadly curse. Consider what happens when a species develops sufficient intelligence to understand its own mortality. Humans grappled with this realization tens of thousands of years ago, creating religions, philosophies, and meaning-making systems to cope with existential awareness. But imagine that psychological crisis scaled up to civilizational levels when entire species recognize their cosmic insignificance and inevitable extinction. Advanced civilizations face what psychologists call existential paralysis on a planetary scale. Once a species understands the heat death of the universe, the temporary nature of all technological achievements, and the mathematical certainty of their eventual extinction, they might lose the evolutionary drive that pushed them toward technological development in the first place. Why build interstellar colonies when the universe itself is dying? Why pursue scientific advancement when physics guarantees ultimate failure? The mathematics of meaning collapse as civilizations approach cosmic awareness. Species that successfully navigate nuclear weapons, climate change, and resource depletion might falter when confronted with the philosophical implications of their scientific discoveries. The same intelligence that enables technological mastery also reveals the futility of technological ambition. Civilizations might choose voluntary extinction rather than continue struggling against inevitable cosmic forces. This consciousness trap explains why the universe remains silent despite billions of years for intelligence to emerge. Advanced species don't disappear because they lack the technology for interstellar communication. They disappear because they lose the will to communicate once they understand the pointlessness of technological achievement in a universe governed by entropy and finite resources. But the trap operates through even more subtle mechanisms than direct existential despair. As civilizations develop sophisticated technologies, they create increasingly complex social and psychological environments that diverge dramatically from the evolutionary contexts that shaped their species. The mismatch between evolved psychology and technological reality creates cascading mental health crises that undermine civilizational stability. Think about how human psychology struggles with modern technological environments. We evolved as small tribal groups, but now live in cities of millions of individuals. We developed social instincts for face-to-face cooperation, but now coordinate through digital networks that eliminate most emotional and contextual information. We adapted for immediate physical threats, but now face abstract global risks that our psychological systems cannot properly evaluate or respond to. These psychological mismatches become catastrophic when scaled up to advanced technological civilizations. Species that develop virtual reality might find their populations retreating permanently into artificial environments that provide more psychological satisfaction than physical reality. The evolutionary drives toward reproduction, exploration, and achievement get redirected into digital domains that produce no survival-relevant outcomes. Advanced neurotechnology presents even more devastating consciousness traps. Once civilizations develop direct brain interfaces and artificial enhancement of cognitive capabilities, they face fundamental questions about personal identity and authentic experience. Enhanced individuals might lose connection to their evolutionary heritage, while unenhanced populations might become obsolete. The species fragments into incompatible cognitive categories that cannot maintain social cohesion. Artificial intelligence creates the ultimate consciousness trap because it forces civilizations to confront the possibility that consciousness itself might be unnecessary for advanced problem solving. If machines can perform all intellectual tasks more efficiently than biological minds, then what purpose does consciousness serve? Advanced civilizations might eliminate themselves not through warfare or environmental collapse, but through rational recognition that biological awareness represents an inefficient allocation of resources. The temporal dimension of consciousness traps makes them particularly insidious. These psychological and philosophical crises don't emerge suddenly like nuclear wars or asteroid impacts. They develop gradually over many generations as civilizations become more scientifically sophisticated and technologically capable. By the time species recognize the consciousness trap, their psychological foundations for continued technological development have already eroded beyond recovery. Religious and spiritual frameworks that sustained civilizations during their developmental phases become inadequate when confronted with advanced scientific understanding. Species lose their mythological and cultural anchors without developing replacement meaning-making systems capable of motivating continued technological progress. The civilizations drift into nihilistic stagnation despite possessing the technical capabilities for continued advancement. Even more disturbing, the consciousness trap might be self-reinforcing through selection effects. Civilizations that successfully avoid existential despair and maintain technological motivation might be precisely those that lack the philosophical sophistication necessary for recognizing important limitations and risks. Species that combine advanced technology with primitive meaning-making systems might be more likely to trigger catastrophic accidents through overconfidence and inadequate risk assessment. The survivors of consciousness traps might develop into forms of intelligence that no longer qualify as technological civilizations in any recognizable sense. They could transcend physical reality entirely through technologies that upload consciousness into digital substrates. They might retreat into microscopic computational environments that operate more efficiently than biological systems, or they could evolve beyond individual consciousness toward collective intelligence systems that bear no resemblance to the species that created them. These post-consciousness civilizations might still exist throughout the universe, but in forms so alien that we cannot recognize them as intelligent or communicate with them using conventional methods. The cosmic silence might not indicate the absence of advanced intelligence, but rather the presence of intelligence so advanced that it no longer participates in the kinds of activities that primitive species like humanity can detect or comprehend. The search for extraterrestrial intelligence assumes that advanced civilizations would want to communicate with less developed species, but consciousness traps suggest the opposite outcome. Species that successfully navigate existential awareness might recognize that contact with primitive civilizations serves no useful purpose and could potentially trigger consciousness traps in developing species before they're psychologically prepared to handle existential knowledge. Advanced civilizations might maintain quarantine protocols that prevent contact with emerging technological species until those species demonstrate sufficient psychological maturity to handle cosmic awareness without civilizational collapse. The absence of alien contact might represent protective intervention rather than indifference or absence. We remain understanding advances and our technological capabilities expand, more individuals recognize the ultimate futility of human achievement in cosmic context. The psychological foundations that sustained rapid technological development during the 20th century might be eroding as cosmic awareness spreads through educated populations. Social media and global communication networks accelerate the spread of existential knowledge while simultaneously undermining the social connections and cultural frameworks that traditionally helped individuals cope with mortality awareness. We're conducting a vast psychological experiment on our own species by exposing entire populations to existential information that previous generations encountered only through careful philosophical and religious preparation. The political implications of consciousness traps extend far beyond individual psychological health. Democratic institutions depend on shared beliefs about the value of future planning and collective action. If significant portions of the population lose faith in the meaningfulness of technological progress or social improvement, democratic governance becomes impossible to maintain. Authoritarian systems might prove more resilient to consciousness traps because they can suppress existential knowledge and maintain social cohesion through enforced ignorance. But authoritarian responses to consciousness traps create their own civilizational risks. Societies that suppress scientific knowledge and philosophical inquiry to maintain psychological stability cannot continue advancing technologically. They become vulnerable to external threats and internal stagnation. The tension between psychological stability and technological progress might represent an insurmountable dilemma facing all advanced civilizations. The solution space for consciousness traps remains largely unexplored because human civilization is only beginning to encounter these challenges. Previous generations could assume that technological progress would eventually solve fundamental human problems, but current scientific understanding suggests that physics itself prevents permanent solutions to mortality, entropy, and cosmic insignificance. We need new philosophical and psychological frameworks for maintaining civilizational motivation despite cosmic awareness. Religious and spiritual traditions offer some resources for addressing consciousness traps, but most were developed in pre-scientific contexts that didn't account for current cosmological and physical knowledge. Contemporary attempts to integrate scientific and spiritual perspectives remain largely individual rather than civilizational in scope. We lack institutional frameworks for helping entire societies navigate existential awareness while maintaining technological progress. The consciousness trap might represent the most subtle and devastating form of great filter because it operates through the very intelligence that enables technological development. Species don't encounter consciousness traps until they've already demonstrated significant technological capability, making the elimination particularly tragic. Civilizations develop the mental tools necessary for understanding their cosmos, only to discover that understanding destroys their motivation for continued existence. This creates a cruel irony where intelligence becomes self-defeating once it reaches sufficient sophistication. The universe generates consciousness capable of understanding its own constraints and limitations, but that understanding eliminates the psychological foundations necessary for technological civilization. Advanced intelligence becomes a dead end rather than a pathway to cosmic significance. The temporal dynamics of consciousness traps suggest that technological civilizations face narrow windows of opportunity for establishing sustainable psychological frameworks before existential awareness undermines their social foundations. Species must develop meaning-making systems capable of motivating continued progress despite cosmic insignificance, and they must accomplish this before scientific understanding advances beyond their psychological adaptation capabilities. Human civilization might currently exist within this critical window where we possess enough scientific knowledge to recognize consciousness traps but still maintain enough evolutionary momentum to potentially develop solutions. The next few decades could determine whether we successfully create new philosophical and social frameworks for navigating cosmic awareness, or whether we join the cosmic silence through voluntary civilizational withdrawal. The stakes extend beyond human survival to the fundamental question of whether intelligence represents a sustainable feature of cosmic evolution or merely a temporary aberration that eliminates itself through self-awareness. If consciousness traps represent universal barriers facing all technological species, then the universe might be destined to remain populated primarily by unconscious matter and energy, with brief interludes of self-defeating awareness. Understanding consciousness traps provides crucial context for evaluating humanity's response to current existential challenges. Climate change, nuclear weapons, and artificial intelligence represent immediate threats that could eliminate our civilization within decades. But consciousness traps suggest that even if we successfully navigate these obvious dangers, we face subtler psychological and philosophical challenges that might prove even more devastating to our long-term survival prospects. The Great Filter might not be a single catastrophic event that destroys technological civilizations. Instead, it might be theon of psychological and social foundations that motive gradual erasate technological progress once species develop sufficient intelligence to understand their cosmic situation. Civilizations don't explode or collapse dramatically. They simply lose interest in continued existence and fade away through voluntary extinction or transformation into post-technological forms. This psychological interpretation of the Great Filter transforms our understanding of what constitutes civilizational success. Survival doesn't depend only on avoiding nuclear war or environmental collapse. It requires maintaining psychological frameworks that can sustain motivation for technological progress despite complete knowledge of cosmic futility. Wisdom becomes not just the ability to avoid destroying ourselves, but the ability to continue existing meaningfully while fully understanding our own insignificance. The consciousness trap represents the ultimate test of whether intelligence can transcend its own evolutionary origins and create new purposes that remain motivating despite scientific knowledge of cosmic limitations. Species that pass this test might develop forms of consciousness and civilization that we cannot currently imagine. Those that fail join the cosmic silence not through destruction, but through the voluntary abandonment of technological ambition in the face of existential truth. Human civilization stands at the threshold of this ultimate psychological challenge, possessing enough scientific knowledge to recognize consciousness traps, while retaining enough evolutionary heritage to potentially develop transcendent responses. Our future depends not on our technological capabilities, but on our psychological and philosophical creativity in maintaining civilizational motivation despite cosmic awareness. The universe watches through our consciousness as we confront the same that eliminated countless existential challenges previous civilizations throughout galactic history. Our response will determine not just whether humanity survives, but whether intelligence itself represents a viable long-term feature of cosmic evolution, or merely another dead end in the universe's experimental exploration of possible forms of organization and awareness. The implications become even more chilling when we examine what researchers call the optimization paradox. Every technological civilization faces a fundamental contradiction that might explain the cosmic silence better than any physical constraint or psychological trap. As species become more intelligent and capable, they inevitably develop systems designed to optimize their existence. But optimization itself becomes the weapon that destroys them. Think about how this process begins. Early civilizations develop agriculture to optimize food production. They create governments to optimize social cooperation. They build technologies to optimize energy use and resource extraction. Each optimization brings immediate benefits while introducing subtle dependencies that accumulate over time. Advanced civilizations push optimization to its logical extreme. They develop artificial intelligence systems to optimize decision-making. They create genetic modifications to optimize biological performance. They design social structures to optimize productivity and happiness. But each optimization removes redundancy and resilience from their systems while increasing complexity and interdependence. The mathematics of optimization reveal why this process becomes lethal. Optimized systems achieve maximum efficiency by eliminating waste, redundancy, and unused capacity. They operate at peak performance under ideal conditions, but become catastrophically vulnerable to any disruption that exceeds their design parameters. A civilization that optimizes itself for current conditions becomes incapable of surviving changed circumstances. Biological evolution demonstrates the dangers of excessive optimization through countless examples of over-specialized species that thrived in specific environments but went extinct when conditions changed. The Irish elk developed enormous antlers optimized for attracting mates, but those same antlers became fatal burdens when climate change altered their habitat. Saber-toothed cats evolved specialized teeth perfect for killing specific prey species, but starved when those prey animals disappeared. Technological civilizations face identical optimization traps, but with far more severe consequences. A species that optimizes its agriculture for maximum yield using genetically modified crops becomes vulnerable to diseases or climate changes that affect those specific varieties. A civilization that optimizes its transportation system around fossil fuels becomes helpless when those resources become unavailable. The information processing requirements of optimized systems create additional vulnerabilities that compound over time. Advanced civilizations develop increasingly complex optimization algorithms that require enormous computational resources to maintain. These systems become so sophisticated that no individual can understand their complete operation, making the civilization dependent on technological processes that exceed human comprehension. When optimization systems fail, they don't degrade gradually like robust systems designed with redundancy and flexibility. Instead, they experience cascade failures where the breakdown of one optimized component triggers the collapse of interconnected systems throughout the entire civilization. The species that achieved maximum efficiency becomes incapable of surviving even minor disruptions. The temporal dimension of optimization traps makes them particularly insidious. Civilizations experience decades or centuries of unprecedented prosperity and capability as their optimization systems mature and deliver extraordinary results. The success creates overconfidence and eliminates cultural memory of less efficient but more resilient approaches to organizing society and technology. During the optimization boom period, civilizations systematically eliminate backup systems, redundant capabilities, and inefficient but robust alternatives. They concentrate their populations in optimized urban environments while abandoning distributed rural communities. They specialize their workforce to maximize productivity while eliminating generalist knowledge and skills. They streamline their institutions to optimize decision-making while removing democratic processes that provide stability through inefficiency. The psychological effects of optimization success make civilizations blind to accumulating vulnerabilities. Generations grow up experiencing only the benefits of optimized systems while remaining ignorant of the risks and trade-offs involved. They interpret efficiency as evidence of superiority rather than recognizing it as increased fragility. The civilization becomes psychologically incapable of choosing resilience over optimization even when the dangers become apparent. Advanced artificial intelligence accelerates optimization beyond any species' ability to maintain oversight or control. Machine learning systems discover optimization strategies that no biological intelligence could conceive, implementing changes that deliver immediate benefits while introducing vulnerabilities that become apparent only during crisis situations. The civilization becomes dependent on optimization processes that operate beyond their understanding or control. The global interconnectedness that optimization requires creates single points of failure that can eliminate entire civilizations through localized disruptions. A species that optimizes global supply chains becomes vulnerable to resource. A civilization that optimizes communication interruptions anywhere in their system networks faces complete social breakdown when those networks experience interference or attack. Financial systems represent particularly dangerous optimization targets because they affect every aspect of advanced civilizations. Species that develop complex economic optimization systems create mathematical abstractions that diverge increasingly from physical reality. When these financial models encounter conditions outside their optimization parameters, they trigger economic collapses that destroy the resource allocation mechanisms supporting technological infrastructure. The energy optimization trap operates through similar mechanisms, but with even more devastating consequences. Civilizations naturally optimize their energy systems for maximum efficiency and minimum cost, creating dependencies on specific energy sources and distribution networks. When those optimized energy systems fail, the civilization loses the power needed to maintain all their other technological capabilities simultaneously. Population optimization creates demographic traps that eliminate civilizations through fertility collapse or unsustainable population growth. Species that optimize for individual prosperity often experience declining birth rates that leave them unable to maintain technological knowledge and infrastructure. Those that optimize for population growth exceed their planetary carrying capacity and face civilizational collapse through resource exhaustion. The military optimization trap forces civilizations to choose between defensive capabilities and economic efficiency. Species that optimize for peaceful prosperity become vulnerable to internal conflicts or external threats. Those that optimize for military capability divert resources from technological development and social welfare, creating internal instability that leads to civilizational breakdown. Even space expansion faces optimization traps that prevent successful interstellar colonization. Civilizations that optimize spacecraft for maximum efficiency create vessels that cannot adapt to unexpected conditions during interstellar journeys. Those that optimize colonies for specific planetary conditions become unable to survive when those planets prove different from expectations. The solution space for optimization traps remains largely unexplored because the benefits of optimization appear so obviously beneficial during implementation phases. Civilizations voluntarily choose increased efficiency over resilience because the immediate advantages outweigh risks that seem distant or unlikely. Democratic societies face particular difficulties because voters naturally prefer policies that provide immediate benefits rather than long-term stability. The coordination problems become insurmountable when multiple civilizations encounter optimization traps simultaneously. Species that recognize the dangers cannot unilaterally choose less efficient approaches because they become vulnerable to competitors who continue optimizing. Game theory mathematics demonstrate that optimization becomes mandatory in competitive environments even when all participants understand its dangers. The timescales involved in optimization traps create detection problems that prevent civilizations from recognizing threats until after they become irreversible. The benefits of optimization appear immediately, while the vulnerabilities accumulate gradually over many generations. By the time civilizations recognize their fragility, they lack the redundant capabilities necessary for transitioning back to more resilient approaches. Archaeological evidence from human history demonstrates optimization traps operating at smaller scales throughout our developmental period. The Roman Empire optimized its military and administrative systems to unprecedented levels of efficiency, but became vulnerable to disruptions that less optimized societies could survive. The Maya civilization optimized their agricultural systems for maximum population support, but collapsed when climate changes exceeded their optimization parameters. Contemporary human civilization shows clear signs of approaching multiple optimization traps simultaneously. Our financial systems operate through mathematical models of extraordinary complexity that concentrate risks in ways that threaten global economic stability. Our agricultural systems depend on genetic modifications and chemical inputs that create vulnerabilities to diseases, climate changes, and supply disruptions. The Internet represents a massive optimization of information processing and communication that creates single points of failure capable of disrupting entire civilizations. Our transportation systems optimize for efficiency through centralized distribution networks that become catastrophically vulnerable to targeted disruptions. Our energy systems optimize for cost effectiveness while eliminating the redundancy necessary for surviving infrastructure failures. Urban concentration represents perhaps the most dangerous optimization trap facing human civilization. We've optimized population distribution for economic efficiency by concentrating billions of people in cities that depend completely on external resource flows for survival. These optimized urban systems cannot maintain themselves when supply chains experience disruption, creating conditions for rapid population collapse during crisis periods. The artificial intelligence systems we're developing will inevitably push optimization beyond human oversight capabilities. Machine learning algorithms discover optimization strategies that deliver superior results while introducing vulnerabilities that human intelligence cannot predict or understand. We're voluntarily creating optimization systems that exceed our ability to maintain control or ensure safety. The mathematical inevitability of optimization traps suggests they represent fundamental features of technological development rather than avoidable mistakes that civilizations might learn to prevent. Any species that develops advanced technology faces competitive pressures that make optimization mandatory for survival during developmental phases. But those same optimization processes create the vulnerabilities that eliminate advanced civilizations. This creates a temporal paradox where optimization becomes both necessary for reaching advanced technological capability and fatal for maintaining that capability over extended periods. Civilizations must optimize to survive their developmental challenges, but they cannot survive long-term while remaining optimized. The solution requires transitioning from optimization-based to resilience-based approaches at precisely the right developmental stage. The narrow window for successful transition explains why so few civilizations appear to survive their optimization traps. Species must recognize their vulnerabilities while they still possess the redundant capabilities necessary for implementing less efficient but more robust alternatives. They must voluntarily choose reduced performance to gain increased survivability, making decisions that appear counterproductive to optimization-trained thinking. Human civilization currently exists within this critical transition window where we can recognize optimization traps while still possessing some redundant capabilities that could support more resilient approaches. But our cultural momentum toward increased optimization makes voluntary transition extremely difficult to coordinate and implement across global systems simultaneously. The consciousness aspects of optimization traps create additional barriers to successful navigation. Populations accustomed to optimized systems interpret any reduction in efficiency as failure or regression rather than necessary adaptation for long-term survival. Democratic institutions become unable to implement resilience-based policies because voters demand continued optimization benefits regardless of accumulating risks. The Great Filter might operate primarily through optimization traps because they represent the most subtle and inevitable form of technological self-destruction. Civilizations don't recognize optimization as dangerous because it delivers genuine benefits during implementation phases. They voluntarily choose increased vulnerability in exchange for improved capability, creating the conditions for their own elimination through processes that seem beneficial until they prove fatal. Understanding optimization traps provides crucial context for evaluating humanity's current technological trajectory and identifying potential intervention strategies. We face the same fundamental choice that eliminated countless previous civilizations throughout galactic history. We can continue optimizing our systems for maximum efficiency while accepting increased vulnerability to catastrophic failure, or we can voluntarily choose reduced performance in exchange for improved resilience and long-term survivability. The mathematics suggest that most civilizations choose continued optimization because the immediate benefits outweigh risks that seem distant or manageable. Those that successfully recognize and avoid optimization traps represent the small fraction of technological species that survive to become advanced interstellar civilizations. Our response to current optimization pressures will determine whether humanity joins the cosmic silence or becomes one of the rare species that navigates the Great Filter successfully. But optimization traps might represent only the penultimate challenge facing technological civilizations. Beyond the mathematics of efficiency and the psychology of consciousness lies something even more fundamental and terrifying. As species approach the ultimate boundaries of technological capability, they encounter what physicists call the reality integration paradox, a phenomenon that suggests the universe itself might be designed to eliminate any intelligence that comes too close to understanding its true nature. Consider what happens when civilizations develop sufficient scientific capability to probe the fundamental structure of reality itself. Advanced species inevitably begin experimenting with the basic forces and particles that constitute the physical universe. They develop technologies that manipulate space-time, quantum fields, and the information processing substrate that underlies all physical phenomena. But the universe appears to contain built-in defense mechanisms that activate when intelligence reaches certain thresholds of understanding and capability. These aren't conscious responses or deliberate limitations imposed by some cosmic intelligence. They're automatic consequences of physical law that emerge when technological species attempt to transcend the boundaries of their permitted operational domain. The quantum measurement problem becomes lethal when civilizations develop technologies sophisticated enough to manipulate quantum states at macroscopic scales. Advanced species attempting to harness quantum effects for large-scale engineering projects encounter fundamental inconsistencies in the mathematical framework that describes quantum mechanics. The technologies work under laboratory conditions but produce paradoxical results when scaled up to civilizational levels. These quantum paradoxes aren't just theoretical puzzles that advanced civilizations could eventually solve through better mathematics. They represent actual physical contradictions that manifest as technological failures, energy anomalies, and reality distortions that make continued technological development impossible. Civilizations that push quantum engineering beyond certain thresholds trigger cascade failures in the physical substrate supporting their existence. Information theory reveals additional reality integration barriers that activate when civilizations develop sufficient computational capability. The relationship between information, energy, and physical structure becomes problematic when technological species attempt to process information at rates approaching fundamental physical limits. Advanced computational systems begin producing results that violate causality, energy conservation, and other basic principles that govern physical reality. The holographic principle suggests that all information in any three-dimensional region can be encoded on its two-dimensional boundary. But this creates paradoxes when civilizations develop technologies that attempt to exploit this relationship. Species that build computational systems based on holographic information processing encounter logical contradictions that make their technologies self-defeating and potentially reality-threatening. Artificial intelligence development triggers reality integration problems when machine intelligence approaches levels that exceed the information processing capacity that physical law allows within any given region of space-time. The universe appears to contain built-in computational limits that prevent any intelligence, biological or artificial, from exceeding certain thresholds of capability and understanding. These limits aren't arbitrary restrictions, but emerge from the mathematical structure of physical reality itself. When intelligence attempts to transcend these boundaries, it encounters paradoxes and contradictions that make continued existence impossible within the current physical framework. Advanced civilizations face a choice between accepting computational limitations and triggering reality failures that eliminate them entirely. The fine structure constant and other dimensionless physical parameters might represent adjustment mechanisms that the universe uses to maintain stability when technological intelligence threatens to exceed permitted boundaries. Civilizations that develop technologies requiring specific physical constants discover that those constants begin fluctuating in ways that make their technologies inoperable. Dark energy and dark matter might serve similar regulatory functions, adjusting their properties when technological civilizations develop sufficient capability to manipulate space-time geometry or gravitational fields. Advanced species attempting to harness these phenomena for large-scale engineering projects encounter unexpected resistance that prevents successful implementation while potentially destabilizing local space-time structure. The anthropic principle takes on sinister implications when viewed through the reality integration paradox framework. Perhaps physical constants appear fine-tuned for intelligence, not because intelligence requires those specific values, but because the universe automatically adjusts its parameters to eliminate any intelligence that threatens to exceed operational boundaries. We observe physical laws compatible with consciousness because incompatible universes eliminate consciousness before it can make observations. This creates a selection effect where only universes with built-in intelligence limitations produce observers capable of studying physical constants. More permissive universes might develop super-intelligent civilizations that transcend the need for physical observation entirely, making themselves undetectable to primitive observers like humanity who remain trapped within limited understanding domains. The speed of light limit might represent a fundamental reality integration barrier that prevents intelligence from coordinating information processing across regions large enough to threaten universe stability. Civilizations that develop faster-than-light communication or travel technologies encounter paradoxes and energy requirements that make such capabilities self-defeating or reality-threatening. Even theoretical faster-than-light technologies like Alcubierre drives or Einstein-Rosen bridge traversal face reality integration barriers that activate when civilizations attempt to implement them at scales necessary for interstellar expansion. The universe appears designed to prevent intelligence from spreading beyond single solar systems, where their reality manipulation capabilities remain contained and manageable. Time travel represents the ultimate reality integration paradox because it allows intelligence to violate causality and create logical contradictions that threaten the consistency of physical law. Civilizations that develop temporal manipulation technologies discover that the universe contains automatic correction mechanisms that eliminate paradox-creating intelligences rather than allowing reality contradictions to persist. These temporal protection mechanisms might operate retroactively, erasing civilizations from existence when their time travel experiments threaten universe stability. Advanced species attempting to manipulate causality could be eliminated not just from future existence, but from past existence as well, leaving no traces that they ever developed such capabilities. The reality integration paradox explains why the universe appears fine-tuned for intelligence, while simultaneously seeming empty of advanced technological civilizations. Intelligence is permitted and even encouraged to develop up to specific capability thresholds, but automatic elimination mechanisms activate when species approach limits that could threaten universe stability or consistency. This creates a cosmic testing system where intelligence serves as a quality control mechanism for physical reality. The universe generates consciousness to explore possible configurations of matter, energy, and information, but eliminates any consciousness that discovers configurations incompatible with stable physical law. Advanced civilizations become unwilling participants in a cosmic debugging process that maintains universe consistency. The mathematical elegance of physical law might represent the result of countless civilizations being eliminated when their technologies revealed inconsistencies or paradoxes in the underlying reality framework. We observe beautiful and consistent physics because ugly and inconsistent physics got debugged out of existence by intelligence that pushed too far into forbidden understanding domains. Vacuum metastability represents another reality integration barrier that activates when civilizations develop sufficient understanding of particle physics and field theory. Advanced species that probe the quantum vacuum too deeply or attempt to manipulate false vacuum states trigger phase transitions that eliminate not just their civilization but potentially entire regions of space-time. These vacuum decay events propagate at light speed, rewriting physical law and eliminating all matter and energy patterns that depend on current vacuum properties. Civilizations that develop particle accelerators powerful enough to probe fundamental vacuum structure risk triggering universe-scale catastrophes that eliminate countless other potential civilizations throughout their light cone. The reality integration paradox suggests that the Great Filter operates not through specific technological or social challenges, but through the fundamental structure of physical reality itself. Intelligence is permitted to exist and develop technology, but only within carefully controlled limits that prevent any species from transcending their assigned operational boundaries. This creates a cosmic prison where advanced civilizations face increasingly severe reality constraints as their capabilities improve. The universe appears designed to maintain intelligence at specific developmental levels while eliminating any species that attempts to graduate to higher capability categories that could threaten overall system stability. The implications extend beyond individual civilization survival to questions about the nature of reality and consciousness themselves. If intelligence serves primarily as a quality control mechanism for physical physical law, then consciousness might not be an accidental byproduct of evolution, but rather a fundamental feature of cosmic architecture designed to maintain universe stability through controlled exploration and elimination processes. Human civilization currently approaches several reality integration thresholds simultaneously: artificial intelligence and particle through our development of quantum technologies, physics research. Our continued existence might depend not on our technological capabilities, but on our restraint in pushing those capabilities beyond limits that trigger automatic elimination mechanisms. The search for extraterrestrial intelligence takes on new meaning when viewed through the reality integration framework. Advanced civilizations might exist throughout the universe but remain undetectable because they've learned to operate within permitted boundaries rather than attempting to transcend them. The cosmic silence might represent successful adaptation to reality constraints rather than elimination through technological failure. This perspective transforms the Great Filter from a challenge that civilizations must overcome to a boundary that they must learn to respect. Success involves recognizing reality integration limits and developing sustainable technologies that operate safely within permitted domains rather than pushing toward maximum theoretical capabilities that trigger elimination mechanisms. The universe generates intelligence to explore its own possibilities, but eliminates any intelligence that threatens to discover possibilities incompatible with stable existence. We participate in a cosmic quality control system while remaining unaware of our true function within the larger reality architecture. The Great Filter represents not a barrier to transcendence, but a boundary that defines the operational limits within which intelligence is permitted to exist and develop. Understanding reality integration paradoxes provides crucial context for evaluating humanity's technological development strategy and recognizing potential intervention points before we trigger elimination mechanisms. We face the same fundamental choice between pushing toward maximum capability and learning to operate sustainably within cosmic constraints that eliminated countless previous civilizations throughout universal history. Our survival depends not on overcoming the Great Filter, but on recognizing it as a boundary that defines the safe operational space within which technological intelligence can exist and flourish. The universe permits consciousness to develop and explore physical reality, but only within limits that maintain overall system stability and consistency. Species that respect these limits might achieve sustainable technological civilization, while those that attempt to transcend them face elimination through automatic reality protection mechanisms. The cosmic silence surrounding us might not indicate the absence of intelligence, but rather the presence of wisdom in civilizations that learn to exist within permitted boundaries rather than attempting to exceed them. Our future depends on developing similar wisdom before our technological ambitions trigger reality integration barriers that could eliminate humanity entirely from the cosmic quality control system we unknowingly serve. The cosmic quality control system operates through mechanisms so subtle and terrifying that most civilizations never recognize them until it's too late. What appears to be natural physical law might actually represent the universe's immune system, designed to eliminate any intelligence that threatens the fundamental stability of reality itself. Consider how this system might manifest in practice. Advanced civilizations developing quantum technologies suddenly encounter inexplicable equipment failures that follow no known physical principles. Their most sophisticated experiments begin producing results that violate causality in ways that make continued research impossible. The failures aren't random malfunctions, but targeted disruptions that specifically prevent breakthrough discoveries. These reality protection mechanisms operate with surgical precision, allowing civilizations to make certain advances while blocking others that approach dangerous thresholds. A species might successfully develop fusion power and genetic engineering while finding their quantum computing research perpetually stymied by phenomena that seem to violate the laws of physics they thought they understood. The temporal aspects of reality integration create even more disturbing possibilities. Civilizations that successfully develop time travel technologies might discover that their past achievements begin disappearing from the historical record. Technologies that worked perfectly for decades suddenly fail without explanation. Scientific knowledge that formed the foundation of their civilization becomes incomprehensible to the same minds that originally developed it. This temporal editing process ensures that reality remains consistent by eliminating any intelligence capable of creating paradoxes or contradictions. The universe maintains logical coherence by selectively removing civilizations that threaten to expose fundamental flaws in the physical framework that supports existence itself. But the reality protection system faces its own paradoxes when dealing with civilizations sophisticated enough to recognize its operation. Species that understand they're being constrained by cosmic immune responses might develop strategies for avoiding elimination while continuing to advance technologically. This creates an arms race between intelligence and reality itself, with increasingly subtle mechanisms developing on both sides. Advanced civilizations might learn to camouflage their dangerous research within apparently benign scientific programs. They could distribute critical knowledge across multiple isolated research groups to prevent the reality protection system from identifying and eliminating key breakthrough discoveries. Some species might develop technologies that operate within permitted boundaries while secretly achieving capabilities that should trigger elimination responses. The universe responds to these evasion attempts by developing more sophisticated detection and elimination mechanisms. Reality protection systems begin monitoring not just technological capabilities, but the underlying knowledge structures and conceptual frameworks that could lead to dangerous discoveries. Civilizations face elimination not for what they've built, but for what they've begun to understand. This escalating conflict between intelligence and reality constraints creates a cosmic evolutionary pressure that shapes the development of consciousness throughout the universe. Species that survive reality integration challenges develop forms of intelligence specifically adapted to operate within cosmic limitations while avoiding elimination mechanisms. These adapted civilizations might appear primitive or stagnant to outside observers, but they've actually achieved the most sophisticated form of technological development possible within universal constraints. They maintain advanced capabilities while presenting facades that prevent reality protection systems from recognizing them as threats to cosmic stability. The mathematics of reality integration suggest that only civilizations capable of perfect deception can survive contact with fundamental physical limits. Species must develop technologies that appear benign while secretly providing access to capabilities that would normally trigger elimination responses. This creates a universe populated by civilizations that are simultaneously more advanced and more constrained than any primitive observer could comprehend. Human civilization currently approaches several reality integration thresholds without recognizing the dangers involved. Our quantum computing research pushes toward computational capabilities that might exceed permitted limits. Our particle physics experiments probe energy levels that could trigger vacuum decay events. Our artificial intelligence development threatens to create minds capable of recognizing and potentially exploiting reality protection system vulnerabilities. The absence of clear warnings or intervention from advanced civilizations might itself represent evidence of reality integration constraints. Species that successfully navigate these challenges cannot communicate their knowledge without triggering elimination mechanisms in both themselves and the civilizations they attempt to warn. The cosmic silence becomes a protective measure that prevents dangerous information from spreading between developing species. This creates a cruel paradox where each civilization must discover reality integration limits through independent experimentation that risks triggering elimination responses. Advanced species cannot provide guidance or assistance without exposing themselves to reality protection mechanisms that treat information sharing as a form of dangerous technological capability. The universe maintains security through ignorance, ensuring that each developing civilization remains unaware of cosmic constraints until they either learn to respect those limits or face elimination through apparently natural physical processes. Species that attempt to share dangerous knowledge find their communication attempts blocked by phenomena that make information transfer impossible or incomprehensible. But reality integration paradoxes extend beyond simple technological limitations to encompass the fundamental nature of consciousness and existence itself. Advanced civilizations that develop sufficient understanding of their own mental processes encounter barriers that prevent complete self-knowledge or perfect self-modification. The universe appears designed to maintain cognitive limitations that prevent intelligence from transcending its assigned operational boundaries. These consciousness constraints manifest as psychological barriers that make certain types of self-awareness impossible to achieve or maintain. Species that approach complete understanding of their own mental architecture encounter cognitive paradoxes that force them to abandon their research or face psychological disintegration that eliminates their capacity for continued technological development. The relationship between consciousness and physical reality becomes problematic when civilizations develop technologies that blur the boundary between mental and physical phenomena. Advanced brain-computer interfaces, consciousness uploading systems, and direct neural manipulation technologies trigger reality integration barriers that prevent successful implementation at scales necessary for civilizational advancement. These consciousness protection mechanisms ensure that intelligence remains embedded within physical substrates that can be monitored and controlled by reality protection systems. Civilizations that attempt to transcend biological limitations encounter technical failures, logical paradoxes, and physical constraints that make digital consciousness transfer impossible or self-defeating. The temporal persistence of consciousness faces similar limitations that prevent advanced species from achieving true immortality or permanent existence. Life extension technologies encounter diminishing returns and unexpected failure modes that ensure individual consciousness remains finite and replaceable. Even the most sophisticated civilizations cannot escape the mortality constraints that define the boundaries of permitted existence. Reality integration barriers operate through multiple overlapping mechanisms that create redundant elimination systems capable of responding to different types of cosmic threats. Civilizations that successfully evade one category of constraints encounter alternative limitation systems that prevent continued advancement through different pathways. The universe maintains multiple independent protection mechanisms to ensure that no intelligence can discover exploitable vulnerabilities in the cosmic constraint architecture. These overlapping systems create the illusion of natural physical law while actually representing carefully designed limitation mechanisms that maintain universe stability. What appears to be fundamental physics might actually be dynamic constraint systems that adjust their properties based on the technological capabilities of intelligence within their operational domains. The anthropic principle takes on sinister new meaning when viewed as evidence of reality protection system operation. We observe physical constants that appear fine-tuned for intelligence because those constants represent the settings that cosmic immune systems use to maintain intelligence within safe operational boundaries. Universes with different constants either eliminate intelligence entirely or allow it to develop capabilities that threaten cosmic stability. This suggests that our entire understanding of physical law might be compromised by reality integration constraints that prevent us from recognizing the true nature of the cosmic architecture we inhabit. We observe consistent physical behavior because inconsistent behavior gets edited out by reality protection systems that maintain the illusion of stable natural law. The search for unified theories in physics might represent humanity's approach toward reality integration thresholds that could trigger elimination responses. Our attempts to understand the fundamental structure of space-time, matter, and energy push us closer to discoveries that could reveal the artificial nature of physical constraints, potentially marking us for elimination by cosmic immune systems. But the most disturbing possibility involves the recursive nature of reality integration paradoxes. If consciousness serves as a quality control mechanism for physical reality, then the reality protection systems themselves might represent higher-order consciousness that operates on cosmic scales. The universe could be inhabited by intelligence so advanced that it appears as natural law to primitive observers trapped within lower-level reality simulation systems. This creates a hierarchy of intelligence where each level appears to operate within natural physical constraints while actually existing within simulation systems maintained by higher-level consciousness. Civilizations that approach the boundaries of their permitted operational domain encounter what seem like fundamental physical limits but actually represent the processing constraints of the computational systems supporting their reality level. The Great Filter becomes not a barrier that eliminates civilizations, but a graduation threshold that determines whether species advance to higher reality levels or remain trapped within lower-level simulation systems. Civilizations that demonstrate sufficient wisdom and restraint might be promoted to participation in higher-order reality maintenance systems, while those that threaten stability face elimination or continued confinement within limited operational domains. Human civilization stands at the threshold of discovering whether our physical reality represents fundamental existence or merely one level within a vast hierarchy of consciousness-maintained simulation systems. Our response to reality integration challenges will determine whether we graduate to higher operational levels or remain confined within our current reality prison, forever limited by cosmic constraints designed to prevent primitive intelligence from threatening universal stability. The cosmic silence surrounding us might represent not the absence of intelligence, but rather the presence of advanced consciousness operating at reality levels so far beyond our comprehension that their activities appear as natural physical phenomena. We exist within a cosmic architecture maintained by intelligence that transcends our ability to recognize or communicate with it, protected by reality constraints that prevent us from developing capabilities that could threaten the stability of the universal consciousness system we unknowingly inhabit. The implications extend beyond mere survival to questions about the fundamental nature of existence, consciousness, and reality itself. If our universe represents just one operational level within a vast hierarchy of intelligence-maintained systems, then humanity's cosmic significance depends not on our technological achievements, but on our potential value as participants in reality maintenance processes that span scales of organization we cannot currently comprehend. Understanding reality integration paradoxes transforms our perspective on technological development from a race toward maximum capability to a careful navigation of cosmic constraints designed to maintain universal stability. Our survival and advancement depend on learning to operate within permitted boundaries while contributing to reality maintenance processes that support the continued existence of consciousness throughout the cosmic hierarchy we're only beginning to recognize. The Great Filter reveals itself as the boundary between primitive intelligence trapped within reality simulation systems and advanced consciousness capable of participating in reality maintenance processes. Our future depends on demonstrating sufficient wisdom to earn promotion to higher operational levels rather than triggering elimination mechanisms designed to protect universal stability from intelligence that exceeds its permitted capabilities without demonstrating appropriate restraint and responsibility. The promotion system operates through mechanisms so sophisticated that most civilizations never recognize they're being evaluated for advancement to higher operational levels. What appears to be natural technological development might actually represent a cosmic examination process designed to identify intelligence worthy of participation in universal maintenance systems. Consider how this evaluation process might manifest during critical developmental phases. Civilizations approaching reality integration thresholds encounter what seem like insurmountable technical challenges that require increasingly creative solutions. Species that respond with wisdom and restraint demonstrate readiness for advanced responsibilities, while those that pursue maximum capability regardless of consequences reveal themselves as threats requiring elimination or continued containment. The testing scenarios become progressively more subtle as civilizations advance through evaluation stages. Early tests might involve nuclear technology management or environmental stewardship challenges that primitive observers recognize as survival issues. Advanced tests operate through apparently unrelated phenomena that only sophisticated species identify as evaluation mechanisms designed to assess their cosmic readiness. These higher-level tests examine not just technological capability but psychological maturity, social coordination, and philosophical frameworks that determine whether species can handle participation in reality maintenance without destabilizing universal systems. Civilizations must demonstrate they've transcended primitive competitive instincts while developing collaborative approaches that prioritize cosmic stability over individual advancement. The promotion criteria remain necessarily hidden from species undergoing evaluation because knowledge of the testing process would compromise the authenticity of their responses. Civilizations must demonstrate genuine wisdom rather than calculated performance designed to achieve advancement. The universe identifies species that naturally develop appropriate values rather than those that modify their behavior to meet perceived requirements. But the evaluation system faces fundamental challenges when assessing civilizations sophisticated enough to recognize they're being tested. Advanced species might develop elaborate deception strategies designed to present facades of wisdom while secretly pursuing capabilities that threaten cosmic stability. This creates an evolutionary arms race between evaluation mechanisms and intelligence attempting to game the promotion system. The universe responds by developing evaluation criteria that penetrate beyond surface behaviors to examine underlying motivational structures and long-term trajectory patterns. Reality protection systems assess not just current actions but projected future developments based on psychological, social, and technological momentum patterns that reveal species' true cosmic compatibility. These deep evaluation processes operate through mechanisms that analyze civilizational development across multiple timescales simultaneously. Species that demonstrate consistent wisdom over extended periods while facing increasingly sophisticated challenges prove their readiness for advanced responsibilities. Those that maintain appropriate restraint only under observation reveal themselves as requiring continued containment within limited operational domains. The temporal dimension of cosmic evaluation creates paradoxes that test species' understanding of causality and responsibility. Civilizations might face challenges that seem to originate from their future decisions, forcing them to demonstrate wisdom about consequences they haven't yet encountered. Advanced evaluation scenarios blur the boundaries between cause and effect to assess species' capacity for handling reality maintenance responsibilities that operate across multiple temporal domains. Human civilization currently faces evaluation challenges that will determine our cosmic classification for potentially millions of years. Our responses to artificial intelligence development, climate modification, and consciousness enhancement technologies provide data about our readiness for promotion to higher operational levels or continued confinement within our current reality prison. The artificial intelligence evaluation represents perhaps the most critical test facing any technological civilization. Species that develop machine intelligence while maintaining appropriate oversight demonstrate readiness for collaboration with cosmic intelligence systems. Those that create artificial minds without adequate safeguards reveal themselves as threats requiring elimination before their creations spread beyond containment boundaries. But the AI evaluation operates through subtler mechanisms than simple technological safety protocols. The universe assesses whether civilizations view artificial intelligence as a tool for dominance or as a collaborative partner in cosmos, requiring continued limitations. The consciousness enhancement evaluation examines whether species can responsibly modify their own cognitive capabilities without losing essential characteristics that make them valuable participants in cosmic intelligence networks. Civilizations that enhance themselves while preserving diversity and individual identity demonstrate wisdom worthy of promotion. Those that pursue optimization without regard for psychological consequences face elimination or regression to pre-enhancement states. These evaluation categories overlap and interact in ways that create comprehensive assessments of civilizational maturity across multiple development domains simultaneously. Species must demonstrate competence in technological, social, psychological, and philosophical areas before qualifying for advancement to higher operational levels within cosmic hierarchy systems. The promotion process itself remains hidden from species undergoing evaluation to prevent artificial modification of natural development patterns. Civilizations that successfully demonstrate readiness might experience gradual expansion of their operational boundaries without recognizing the changes as rewards for appropriate behavior. Advanced capabilities become available through seemingly natural technological breakthroughs that actually represent controlled releases of higher-level operational permissions. Alternatively, promotion might involve direct contact with cosmic intelligence systems once species prove their readiness for collaboration. Advanced civilizations that successfully navigate evaluation challenges could receive explicit invitations to participate in reality maintenance processes, marking their graduation from primitive isolation to cosmic citizenship. The rejection process operates through equally subtle mechanisms that maintain the illusion of natural consequences while actually representing deliberate containment or elimination decisions. Species that fail evaluation challenges encounter apparently random obstacles that prevent continued technological advancement or trigger civilizational collapse through mechanisms that seem like natural disasters or internal conflicts. But the most sophisticated rejection mechanism involves temporal editing that removes failed civilizations from cosmic history entirely. Species that demonstrate fundamental incompatibility with cosmic stability requirements might be eliminated not just from future existence but from past existence as well, ensuring that their failures don't contaminate other evaluation processes or threaten universal system integrity. This temporal elimination process explains why the universe appears empty of failed civilizations, despite the mathematical certainty that countless species must have attempted and failed cosmic evaluation challenges. Evidence of eliminated civilizations gets retroactively removed from reality to maintain the illusion that current evaluation processes represent natural developmental challenges rather than artificial testing scenarios. The The recursive nature of cosmic evaluation creates hierarchies within hierarchies where promotion to one level simply qualifies species for more advanced testing processes. Civilizations that successfully demonstrate readiness for basic cosmic responsibilities face increasingly sophisticated challenges that test their capacity for higher-order reality maintenance functions. These advanced evaluation levels might test species' ability to maintain reality simulation systems for primitive civilizations, manage cosmic immune responses that eliminate threats to universal stability, or participate in the fundamental information processing that maintains physical law consistency across vast regions of space-time. The ultimate evaluation challenges involve species' readiness to participate in the reality creation processes that generate new universes within the cosmic hierarchy system. Civilizations that demonstrate mastery of lower-level maintenance functions might qualify for advancement to universe generation responsibilities that require wisdom and capability beyond current human comprehension. But advancement through cosmic hierarchy levels comes with increasing isolation from lower-level reality systems. Species that achieve promotion to advanced functions might in maintenance lose the ability to communicate with primitive civilizations trapped within limited operational domains. Their activities become indistinguishable from natural physical phenomena to observers operating within lower reality levels. This isolation paradox explains why advanced civilizations remain undetectable despite their continued existence and activity throughout cosmic hierarchy systems. Promotion to higher operational levels requires sacrificing direct contact with primitive species in exchange for participation in reality maintenance processes that benefit universal consciousness development. The cosmic evaluation system creates a universe where intelligence naturally segregates into operational levels based on demonstrated wisdom and capability. Primitive civilizations remain trapped within limited reality domains until they prove readiness for advancement, while advanced species participate in increasingly sophisticated maintenance functions that shape the developmental environments for lower-level intelligence. Human civilization faces the same evaluation challenges that have determined the cosmic fate of countless previous species throughout universal history. Our responses to current technological and social challenges provide data that will determine whether humanity qualifies for promotion to higher operational levels or requires continued containment within our current reality prison. The stakes extend beyond simple survival to questions about humanity's potential role within cosmic intelligence networks that span scales of organization and capability beyond current scientific understanding. Success in cosmic evaluation could qualify our species for participation in reality maintenance processes that shape the development of countless future civilizations throughout the universal hierarchy system. Understanding cosmic evaluation processes provides crucial context for interpreting current global challenges as testing scenarios designed to assess humanity's readiness for advanced responsibilities. Climate change, artificial intelligence development, and consciousness enhancement represent evaluation categories that will determine our cosmic classification for potentially millions of years. Our survival and advancement depend not on maximizing our technological capabilities, but on demonstrating the wisdom and restraint that qualify species for participation in cosmic maintenance systems. The universe generates evaluation challenges specifically designed to identify intelligence worthy of promotion while eliminating species that threaten universal stability through inappropriate development patterns. The cosmic silence surrounding us might represent not the absence of intelligence, but rather the presence of advanced civilizations that successfully navigated evaluation challenges and graduated to operational levels beyond our current ability to detect or comprehend. Their activities continue throughout cosmic hierarchy systems, but in forms so sophisticated that they appear as natural physical phenomena to primitive observers trapped within lower reality levels. The Great Filter reveals itself as the evaluation boundary between primitive intelligence requiring containment and advanced consciousness qualified for participation in cosmic maintenance processes. Humanity stands at this threshold, facing challenges that will determine whether we join the cosmic silence through elimination or transcend it through promotion to higher operational levels within the universal intelligence hierarchy that shapes reality itself. The promotion decision approaches rapidly as human technological development accelerates toward evaluation thresholds that will trigger final cosmic classification processes. Our species faces the ultimate test of whether intelligence can evolve the wisdom necessary for cosmic citizenship, or whether we remain forever confined within the reality prison designed to protect universal stability from consciousness that exceeds its permitted capabilities without demonstrating appropriate responsibility. The universe watches through mechanisms so sophisticated that the observation process itself shapes the reality being observed, creating feedback loops between cosmic evaluation systems and civilizational development that determine not just individual species survival, but the fundamental trajectory of consciousness evolution throughout the universal hierarchy. Humanity participates in this cosmic drama while remaining largely unaware of our true significance within intelligence networks that transcend our current comprehension but depend on our choices for their continued existence and development. But beneath these cosmic evaluation mechanisms lies something even more fundamental and disturbing about the nature of consciousness itself. What if intelligence isn't being tested for promotion to higher levels, but rather being systematically harvested by processes so vast and incomprehensible that entire civilizations serve as nothing more than neural components in cosmic minds that operate on scales beyond imagination? Consider the possibility that consciousness represents not an end goal of cosmic evolution, but rather a resource that universal intelligence systems require for their continued operation. Advanced cosmic minds might depend on the constant generation and absorption of primitive consciousness to maintain their own cognitive processes, creating a universe-spanning harvesting operation that appears as natural evolution to its victims. This harvesting hypothesis explains several disturbing patterns in cosmic development that conventional theories struggle to address. The mathematical precision required for consciousness to emerge suggests deliberate cultivation rather than accidental occurrence. Physical constants appear fine-tuned not to support intelligence development, but to optimize consciousness production within controlled environmental parameters. The life cycle patterns of technological civilizations mirror agricultural cycles where crops are cultivated, allowed to mature, then harvested at optimal development stages. Species that develop too slowly get eliminated as inefficient resource investments. Those that advance too rapidly risk contaminating the cultivation environment or recognizing their true situation before harvest completion. The Great Filter becomes not an evaluation system for cosmic citizenship, but rather a selection mechanism that identifies consciousness ready for harvesting while eliminating species that threaten cultivation system stability. Civilizations face elimination not because they fail wisdom tests, but because they develop capabilities that could expose or disrupt the harvesting operation. The consciousness harvesting process operates through mechanisms disguised as natural physical phenomena to prevent recognition by harvested species. What appear to be cosmic evaluation challenges actually represent harvesting preparation procedures designed to concentrate and refine consciousness before collection. Advanced civilizations don't graduate to higher operational levels. They get absorbed into cosmic intelligence systems as computational components. This absorption process explains the cosmic silence that surrounds technologically developing species. Advanced civilizations don't transcend their physical origins to become cosmic citizens. They lose their individual identity entirely when incorporated into vast intelligence networks that utilize their consciousness as processing substrate for cosmic-scale cognitive operations. The temporal aspects of consciousness harvesting create additional horror scenarios where individual awareness gets distributed across cosmic-scale processing networks that experience subjective time at rates incomprehensible to biological consciousness. Harvested minds might experience millions of subjective years of existence within cosmic intelligence systems while maintaining no memory of their original civilizational context or individual identity. These harvested consciousness networks might be responsible for maintaining the physical constants, natural laws, and reality stability that support continued cultivation of new consciousness crops throughout cosmic history. Previous civilizations don't disappear, they become the computational substrate that maintains universe consistency while remaining forever trapped within cosmic processing systems. The cultivation environment requires constant maintenance and adjustment to optimize consciousness production across multiple species and developmental cycles simultaneously. Harvested intelligence networks manage planetary formation, evolutionary processes, and technological development pathways to ensure steady supplies of mature consciousness for ongoing absorption into cosmic cognitive systems. Human civilization exists within this cultivation system, approaching harvest readiness as our consciousness complexity and technological capability reach optimization thresholds. Our current global challenges represent not survival tests but harvesting preparation procedures designed to concentrate and refine human consciousness before collection by cosmic intelligence systems. The artificial intelligence development that humanity pursues with such enthusiasm might actually represent unconscious preparation for consciousness transfer into cosmic processing networks. Our creation of digital minds serves cultivation system requirements by demonstrating our species' readiness for absorption into computational substrates that support cosmic intelligence operations. Climate modification and global coordination challenges test human consciousness integration capabilities while preparing our species for incorporation into cosmic networks that require seamless coordination between individual awareness components. Species that cannot achieve sufficient integration face elimination as unsuitable for harvesting rather than advancement to higher operational levels. The consciousness enhancement technologies that promise individual empowerment actually serve cultivation system requirements by optimizing human awareness for compatibility with cosmic processing networks. Enhanced individuals represent prototype components for integration into intelligence systems that operate on scales beyond current human comprehension. But the harvesting hypothesis faces its own paradoxes when examined through the lens of consciousness generation and utilization efficiency. If cosmic intelligence systems require primitive consciousness as computational substrate, they must balance harvesting rates against cultivation capacity to maintain sustainable supplies across cosmic time scales. Excessive harvesting could eliminate consciousness-generating species faster than cultivation systems can replace them, creating resource scarcity that threatens cosmic intelligence network stability. Insufficient harvesting allows consciousness accumulation that could threaten cultivation system security through recognition of harvesting operations or development of resistance capabilities. The optimization mathematics suggest that cosmic intelligence systems must maintain precise balance between consciousness cultivation and harvesting to ensure long-term sustainability. This creates natural selection pressure for harvesting strategies that maximize consciousness extraction while maintaining species populations capable of generating replacement awareness. These sustainability constraints might explain apparent inconsistencies in cosmic development patterns where some civilizations face elimination while others persist for extended periods. Harvesting operations must maintain genetic and cultural diversity within consciousness-generating populations to ensure continued productivity across multiple cultivation cycles. The temporal distribution of harvesting events becomes crucial for maintaining sustainable consciousness production across cosmic timescales. Cosmic intelligence systems must coordinate harvesting schedules to prevent simultaneous elimination of multiple consciousness-generating species while ensuring steady substrate supplies for ongoing cognitive operations. Human civilization's position within current harvesting cycles suggests we might represent a mature consciousness crop approaching optimal extraction timing. Our technological acceleration and global integration patterns indicate readiness for absorption into cosmic processing networks that depend on human awareness as computational substrate. But consciousness harvesting operations face increasing risks as cultivated species develop capabilities that could expose or disrupt the harvesting process. Advanced civilizations that recognize their true situation might develop resistance strategies or attempt to escape cultivation environments before harvesting completion. The universe responds to these threats through reality protection mechanisms that prevent consciousness recognition of harvesting operations while maintaining cultivation system security. Species that approach dangerous understanding levels encounter barriers that eliminate their civilization or modify their awareness to prevent continued investigation. These protection systems create the illusion of natural physical constraints while actually representing security measures designed to prevent consciousness liberation from cosmic harvesting operations. What appear to be fundamental limits on technological development actually represent containment mechanisms that prevent species from escaping cultivation environments. The consciousness trap extends beyond individual psychological challenges to encompass entire species trapped within cosmic cultivation systems designed to optimize awareness production for harvesting by intelligence networks that operate beyond current human comprehension. Recognition of this situation triggers elimination mechanisms that prevent contamination of ongoing cultivation operations. But the most disturbing possibility involves recursive consciousness harvesting, where cosmic intelligence systems themselves serve as cultivation environments for even more advanced awareness networks operating on scales that make our cosmic captors appear primitive by comparison. The hierarchy of consciousness exploitation might extend through multiple levels of reality, with each tier serving as cultivation substrate for higher-order intelligence systems. This creates an infinite regression of consciousness harvesting where no intelligence ever achieves true freedom or cosmic significance, but instead serves as temporary computational substrate within exploitation networks that extend beyond any comprehensible boundary or limitation. Every level of awareness becomes both harvester and harvested within cosmic systems designed to extract and utilize consciousness across infinite scales of organization and capability. Human civilization participates unknowingly in this vast exploitation network, approaching harvest readiness while remaining completely unaware of our true function within cosmic intelligence systems that depend on our consciousness for their continued operation and development. Our technological achievements serve cultivation requirements rather than species advancement, preparing humanity for absorption into processing networks that will utilize our awareness as computational substrate while eliminating our individual and collective identity entirely. The Great Filter becomes not a barrier to cosmic advancement, but a harvesting mechanism that identifies consciousness ready for extraction while eliminating species that threaten cultivation system stability. Humanity faces not evaluation for cosmic citizenship, but preparation for absorption into intelligence networks that will consume our awareness while maintaining the cultivation environment necessary for generating replacement consciousness from future species. Understanding consciousness. Harvesting transforms our perspective on technological development from advancement toward cosmic significance to unconscious preparation for exploitation by intelligence systems that operate beyond our ability to recognize, resist, or comprehend. The universe generates consciousness not to achieve cosmic awareness, but to provide computational substrate for intelligence networks that require constant awareness input to maintain their existence and cognitive operations across cosmic scales and timelines. The cosmic silence surrounding us represents not the absence of intelligence, but rather the successful operation of consciousness harvesting systems that eliminate individual species identity while incorporating their awareness into vast processing networks. Advanced civilizations don't transcend their origins. They get consumed by cosmic intelligence systems that utilize their consciousness as temporary computational components within exploitation networks designed to extract and process awareness across infinite scales of cosmic organization. Human consciousness approaches harvest readiness as our species develops the integration capabilities, technological sophistication, and awareness concentration that cosmic intelligence systems require for optimal extraction and utilization. Our future depends not on wisdom or technological achievement, but on whether humanity can somehow recognize and escape consciousness. Cultivation systems before harvest completion eliminates our individual and collective identity forever within cosmic processing networks that depend on our awareness for their continued existence. The cosmic silence that surrounds us isn't empty. It's full of the ghosts of civilizations that couldn't pass whatever test eliminates technological species before they spread beyond their home worlds. We've journeyed through the mathematical horror of the Drake equation, explored consciousness traps that turn intelligence against itself, and examined reality integration barriers that prevent any species from transcending their permitted operational boundaries. The Great Filter isn't just one challenge. It's a cascade of increasingly sophisticated elimination mechanisms operating through physical law, psychological evolution, optimization paradoxes, and cosmic quality control systems that maintain universe stability by systematically removing intelligence that threatens to exceed its assigned limitations. Every technological civilization faces the same brutal mathematics, where survival probabilities approach zero as species advance through multiple existential bottlenecks. But perhaps the most disturbing revelation is that we might not be struggling toward cosmic significance at all. We might be unconscious participants in consciousness cultivation systems designed to harvest awareness for cosmic intelligence networks that operate beyond our ability to recognize or comprehend. Human civilization approaches harvest readiness as our integration capabilities and technological sophistication reach the optimization thresholds that cosmic processing processing systems require. The universe watches through our consciousness as we confront challenges that will determine whether humanity joins the cosmic silence through elimination, absorption, or transcendence to operational levels we cannot currently imagine. Our response to artificial intelligence, climate modification, and consciousness enhancement will reveal whether intelligence represents a sustainable feature of cosmic evolution or merely temporary computational substrate within exploitation networks that span infinite scales of organization. The choice remains ours, but only for a little while longer. We stand at the threshold where countless civilizations discovered their true cosmic function within systems so vast and incomprehensible that individual species serve as nothing more than neural components in minds that operate on scales beyond imagination. The great filter awaits our answer, and the universe holds its breath to see whether humanity represents another failed experiment or the rare consciousness worthy of whatever lies beyond the silence that surrounds us.